goal seek, as we'll do right now. So for instance, discharge of 500 CFS, bottom width, okay, for this. So we're going to do something different here. I'm going to change this, so I will check on this. I'm going to change this bottom width to 8 feet. And I'm not going to use the 10 feet that's here in the example. I'm going to use 8 feet. So I will know that you did the exercise. You were here and you did the exercise the way we're doing it by changing this to 8 feet. Okay? And I'm also going to change the float to 450. Right? So, as I was saying, you want to get the critical depth in this cell here, right? B19. Right? And you can do it differently, but I'll show you, what you have to do if you want to do this differently. So again, you can do this by, do it trial and error. You can use the goal seek method, or if you do this by hand, I just ask you come in and type the calculated value here of the critical depth, right? So I'm going to use the goal seek. Data, what if analysis, goal seek, set this to our calculated value of Q squared over G. That's 6288.82 by changing the depth. And that's what we get, 4.61, so that's our critical depth. Now we're going to go to the normal depth tab. And again, I want to calculate the normal depth. I have to put in everything that I have, so I'm going to go 450 for the flow, 8 for the bottom width. This is a rectangular channel, so we'll put the side slope to 0. We are given the slope, 0.002, so that's there. We're given the n, 0.015. So I'll put that there, right? Now, again, if you want to go trial and error a little at a time, or you want to do the data goal seek what if analysis, or you want to do it by hand, just to make sure your solution to the normal depth ends up in this particular cell. And again, we'll see why shortly. So I'm going to do what if analysis, goal seek, set Q to 450 by changing this. Okay? So there's our normal depth, right? Now, I'm going to come to the backwater tab. Okay? Over here at the beginning, I'm going to put in all my givens. 450 for the Q, B is 8, side slope 0 to 1, slope of the channel is 0.002, the N number is 0.015, G is that. I'm going to assume a bottom elevation of 100. And that's, you can use that, generally speaking there. That's fine. Okay? Now, what you will see here is that I am doing, in the first column, stations, right? Stations are basically the distances between each step, right? Each step is considered a station, right? So, I can do steps of 50, as long as the step distance is always the same between each row. So right now I'm doing standard step of 200. And I'll leave it like this for now, but you can do 100 at a time. Just make sure each row is 100. In fact, just so you can see, I'm going to do 100 at a time, and you can see, and we'll see what happens, right? All right. In the first column, 1A is the bottom elevation. The bottom elevation should be for station 0. Station 0 is the station right up against the wall. So a distance of 0 upstream of the wall. So the bottom elevation should be 100. That's what I put in here, right? What is the depth of the critical, what is the elevation of the critical depth? Well, if the bottom depth is 100, then the elevation of the critical depth should be 100 plus the critical depth that we calculate. You can see here in this formula, right? I have calculated, I have said, okay, it's going to be the bottom elevation plus what is in the critical depth tab, cell B19, right? And that's why it has to be there. So if you want to change this, you highlight this and you come over to the critical depth tab, and wherever you have your critical depth calculated, you're going to pick that cell and use that. But you don't have to make that change. As long as you make that critical depth calculation in that same cell, then you're fine for that first row. Normal depth, same thing. You can see it's grabbing the normal depth from this cell, right? 100, the bottom elevation, plus that normal depth. Okay? In column 2 is the water surface elevation. This is the data that we're looking for. The water surface elevation. We're trying to do the backwater profile. What are we saying? We're saying, what does the backwater look like as we progress away from the channel? This is the thing that's going to be a trial and error thing. And you'll see the trial and error is not super difficult, right? Right now, based on the example statement, it says the backup is 7 feet at the obstruction, right? That means the water depth is 7 feet there. So the surface elevation of the water should be 7 feet plus the bottom elevation. Before I go forward, let me stop sharing, or let me